Okay, guys, right now you are looking at a notes page that looks like this. And what I'm going to do is go over an example, and then you're going to try the one on your page. So the first one that we're going to look at is for the top. And the question asks, if triangles are similar sizes, what do we do? Well, we're going to use their letters to help us find the corresponding side lengths. And we talked about this already, basically, that the letters are in order. So if it's looking at the one below it, RB in the first one will be the first two letters of your next triangle, KO. Those sides correspond. So like I said, I'm going to do an example first, and then I'm going to have you try one. So if we look here, it says triangle ABC is similar to triangle DEF. And what that means is AB and DE are the same sides. So as I look here, AB is 6 and DE is 8. So in my proportion, we'll line those up. 6 across from 8. And like I said, you do not have to write this one down. Now we're looking for the side DF, which is right here. And if I look here, I'm going to use a different color. DF is the first letter and the last letter. So if I look here, A and C are the first and last letters, which means AC will match to DF. So 6 and 6.5 are a part of the same triangle, which means 8 and X are a part of the same triangle. I could then cross multiply to figure out what the value of X is. So I did that really fast. Hopefully you're ready for this one. So what I want you to do is pause this video and try this one on your own. So as we look here, it says triangle RBS is similar to triangle KOF, and we're looking for the side length KO. So we're looking here. I'm going to start with X, so KO. And if we look at the letters up top, KO is the first two, which means KO matches RB, which is 2.5. So X and 2.5 should go across from each other. You can pick any other side length, kind of. I take that back, you can, because we don't have all the numbers. So we have 7 as a part of X, and 7 is for side KF. I should have used a different color, that's all right. KF, it's the first and the last letter, which means the first and the last letter is RS. So 7 matches to 2.5. So I should cross multiply here, and we're going to get 2.5x equals 7 times 2.5, and what you should find is that x equals 7, which should make sense. If 7 equals 2.5, what should equal 2.5? 7. So x is the missing piece. This will always be here for you. These letters, I promise, they will always be. So if you are somebody who, once they start turning the sides of the triangles and you get lost, that's okay. Not a big deal. The letters will always be here. The next thing that it says under your next column on your page is about scale factor. And scale factor, there's no example here, but all we need to write is the definition of scale factor. And scale factor is the number you multiply by to get the dimensions of the similar shape. So we talked about that yesterday. We just have to figure out what is this entire shape multiplied by to get the other dimensions. That's all you do there. And like I said, there's no example for that one, so we're just going to keep going, but I did want to put that in your notes. The last thing we're going to look at is what happens if there's a triangle inside of a triangle. So like the last one, I'm going to give you an example before you do the one on your page. So do not do this example, just watch. So I've got two triangles here. I'm going to change my color. And we can see right away that x and 2 match. So I'm just going to go ahead and write that up top. We know that x matches to 2. I can see that. But then if we look here, we're just kind of confused because we might not see everything. And we talked yesterday, there are 2 triangles here. There's a smaller one, and I'm actually going to drag this one out so you can see the smaller one, and its dimensions are 2 and 11. Now, I'm going to leave 11 up here. There's also a bigger one. So I'm going to change this to a different color. We've got orange. So we could see now that if I moved this back in, I've got a smaller one with side length 2 here and 11 down the side. And then I'm going to move that back out. I've got this bigger one, which has x here and this entire side. And in order to find this whole side, we're going to have to add 8.5, which is the distance from C to S, and 11, which is the distance from S to T, because we are looking for the whole side, CT. And as we write our proportion, we know that x matches to 2. The other number in x's shape is this whole slant side. So 11 plus 8.5 is 19.5. And 19.5 matches to 11. That was a terrible line, sorry. It's this whole side. That's why we added those. We did 8.5 plus 11 to get 19.5. And that slanty side matches the slanty side of the smaller triangle. It's called the hypotenuse. That's what the slanty side is called. So then we could cross multiply. 11 times x equals 19.5 times 2. That should be 39. And then whenever I divide both sides by 11, that will tell me what x equals. I don't even know what that is. Doesn't matter. That's what that is. So when we're looking at the one that's on your notes, oh goodness, we're looking at that one. Similar thing. There's a missing piece. I'm going to have you do that in a second. I just want to draw attention to one thing before you get started on this example and hit pause. It's this thing. What this means is the whole side is 22. That's not going to help you for your proportion. It won't, because you're not going to use 22. But I just want to point that out because you will see that later today, that if it gives you the whole side, there's nothing to add. It already tells you from C to T, it's 22. Now looking at the bottom, it does not tell you what the whole side length is. It tells you what A to I is and what I to T is. So here's one where you will have to do some math. But if it gives you like this little mark, it's telling you what the whole side length is. And that, you've probably seen that if you've ever looked at like blueprints or anything that requires you to build something. It will usually tell you what the whole side length is, and it should look like that. So with that said, I'm going to have you pause this video and try to figure out what is the value of x here. So go ahead and pause it now. So hopefully you've figured something out. I'm going to start actually by deleting this because like we said, 22 right now, we're not going to need it. It's there in the future if you need an entire side length. And I'm actually going to dump color in my triangles too so that I can see exactly what's going on here. So first and foremost, I'm going to start with x because I know that x in the bigger triangle matches to 4 in the smaller triangle. I'm going to write those across from each other. Let me drag 4 out. Do that. And we'll put 10.5 here. So I know that 4 and 10.5 are a part of my smaller shape. So the question is, if 10.5 is this length, I need that length in the larger triangle. Oh, that line was almost perfect. Dang it. So in order to find that, I'm going to have to add up from A to I, which is 8, and then from I to T, which is 10.5, for a total of 18.5. Hopefully that made sense what we did there. We're going to do some cross multiplying here. We're going to do 4 times 18.5, which should be 74. So 10.5x equals 74. And then if we divide everything by 10.5, this is going to cancel. And then we'll do 74 divided by 10.5, which is something nasty. It's 7.047, blah, blah, blah. We're going to round this to 7.05 because the 7 will round the 4 up to the next number. So you're going to be practicing with some of these today. Before you practice them, I'm going to have you fold this page in half and glue it in your notes. I hope that this made sense. There's only 1 or 2 of these like this today. So hopefully, and again, here's letters too. So we can see C-A-T matches to S-I-T. We hopefully will see that. Okay, I hope this helped. Enjoy your day, guys.